In this video, I'll go through exam questions that cover the criteria draw 3D shapes to include plans and elevations. You can locate the questions on the mathsmath.com website under level 2. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Noah started to build the wall using cubes. This is the first diagram in the instructions. The length of each side of the cubes is 1 centimeter. On the grid below, draw the plan view of the wall once Noah has built this part. So we're going to draw the plan view, which means that looking at this from the top. So when you look at this from the top, you can see 1, 2, 3, 4 squares across. And then we have another one here. One, 2, 3, 4. 1, 2. So double checking now. We've got 1, 2, 3, 4, and then 2 down. So we've done this correctly. Which one of the following is the front elevation of the house from the view shown? So this is the front. We're going to look at it from here, looking at the house from this point. Option C looks like the right one because we've got this rectangle here and then this extension and the roof, so that matches what we see from this point. The rest of the options don't really match the front view. The diagram shows the cross-section of a metal bar. Which one of the following is the side elevation? So this is the side elevation. So looking from this point, what do we see? You can see some rectangles going like this, then another one at the top, another one at the bottom. So that is C. Now we're moving to the calculator questions. Here is a prism. The cross-section of the prism is a pentagon. Draw the front elevation of the prism on the grid. So this is the front. So we're going to draw this here, and we've got to use the scale 1 to 3. So 1 centimeter on the grid is equal to 3 centimeters in reality. So we've got 18 centimeters here, so it will be 3 times smaller on the grid. So 18 divided by 3 gives us 6 centimeters. And we know that this is 1 centimeter on the grid, so it will be 6 square lengths. And we've got this other dimension, which is 15 centimeters. So dividing that by 3 gives us 5. So on the grid, we'll show it using 5 squares, 5 square lengths. This length here, that is equal to 10.5 centimeters because it's the same length as this one. So 10.5, we're going to divide that by 3. Gives us 3.5. And this length here is 4.5 centimeters. So again, 4.5 divided by 3 gives us 1.5 centimeters. We don't need to worry about this one because we can just join these 2 points. So let's start. One, 2, 3, 4, 5, 6. Then we'll go up by 5 centimeters on the left. So 1, 2, 3, 4, 5. Then we'll go 3.5 across. So 1, 2, 3.5. And here we'll go up by 1.5. So 1.5. And we just use the ruler here to join these 2 points. My drawing doesn't look perfect, but you should use a ruler when you do this on paper. Here is a plan view of another building Claire designs. An apprentice draws the front elevation of this building. Which sketch below can be the front elevation for this building? Tick the correct answer. So we have 4 of them. So what we have here at the top of the page is the plan view of the building, and the options show the front elevation of the building. So we've got to match the plan with the front view, with the front elevation. So looking at the first one, they don't seem to match, because looking at the plan view, this seems to be the roof of the building. So it has this line in the middle, and that's not the case here. Looking at the second one, same thing. There is that line missing. Whereas C has got that. So from the top, this would look like this. And D doesn't. So C is the correct option. Maisie is designing packaging for a perfume bottle. The packaging is in the shape of a triangular prism with length 160 millimeters. Maisie has drawn the front elevation and the plan of the prism on the centimeter grid below. Maisie needs to draw the side elevation to complete the design drawings. Draw the side elevation for Maisie. Remember to complete the scale. So the scale is missing, and that would be the first thing to do, to work out the scale. What do we know here? We know that the length of the prism is 160 millimeters. So in centimeters, that will be 16. Centimeters has been represented here, and we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters to 16. So we can divide both numbers by 8, and it will give us 1 to 2. They're both centimeters because we know that each of these is equal to 1 centimeter. So the scale is 1 to 2. Now we're given the front elevation and the plan of the prism. We need to draw the side elevation, which is this one here, in the shape of a rectangle. But how long and how wide? We know that it is 16 centimeters long, so we'll represent it with 8 square lengths here on the grid. One, two, three, 4, 5, 6, 7, 8. What about the width? How wide is it? The triangle at the front shares this edge here, which is also the width of this rectangle that we're drawing. So in reality they have the same length. However, when you look at this from this point, the actual height of the triangle will be equal to that width, because this face is slanted. The rectangle is slanted. It's not standing up straight. So the width of the rectangle will be equal to the height of the triangle that we have at the front. So that will be the same height as the triangle. And I labeled this to say side elevation. We know this is front elevation, and this is the plan view. The volunteers find parts of a building. They think the building used to look like this. Draw the plan view and the side elevation of the building. So plan view, that is from the top. So what we can see from the top is something like this. So like a rectangle, and then we have another 2 rectangles, like extensions here. We have to be careful with the roof, so I'm going to show a line across here for the roof, and we have these 2 lines right in the middle here. But as you can see, this one extends to go to the back, and this one as well extends to go to the back. And I'll need to delete this here and give it more detail. So as you can see, this goes like so. And I'll do that same thing here. This doesn't need to be perfect, but when you do it on paper, use a ruler. And the side elevation we need to draw. that is this one here. So it does look like so. We have a window here and another two smaller windows. The roof. Hopefully my drawing will look better here now when I do it again. Let's double check. That looks like it. You don't need to worry about dimensions here. Just draw it accurately and use a ruler. The company also makes the chocolate bar. It's divided into 10 identical triangle-shaped pieces. Draw a plan view of the bar in the space below. Label the dimensions. So we're going to draw a plan view looking from the top. From the top you can see a rectangle which measures 6 centimeters by 10 centimeters. So that's these dimensions here. And of course you need to use a ruler. I'm going to say 6 centimeters, 10 centimeters. And that's the plan view. One triangular face of the chocolate bar is shown in the diagram. Calculate the size of the angle labeled A. The angles in a triangle add up to 180 degrees. So we have already got 50 and 50, which is 100. Now that is equal to 180, take away 100, which is 80 degrees. This diagram shows the measurements of the ramp. Draw the plan view of the ramp as seen from above. Include the dimensions on your drawing. So when you look at the ramp from above, all you're going to see is a rectangle with these dimensions at the base. So we have 12.88 meters and the width, which is 0.8 meters. The diagram shows the outline of a building. Which one of the above shows the elevation of the left side of the building? The left side of the building is here. So what would we see from that side? That would be two rectangles. So one at the bottom and one at the top. So that would be C. Each of the 4 cubes in this L shape has side length 1 centimeter. On the centimeter grid, draw a plan view of the L shape. From the top, I can only see these faces. So that's what I'm going to show here. 3 of them in a row. And don't forget to include these divisions that separate each face. The diagram shows a 3D shape. Which is the plan view of the shape? Circle the correct letter. So looking from the top, we'll see this and this and this, so 3 square lengths. And then we have this and this, so they come right under these two. So that is C. The cuboid is shown below. Draw the elevation of the cuboid in the direction of the arrow. So what we can see from here is a rectangle which measures 5 centimeters by 2 centimeters. So we need to draw that on the grid, and that will be 5 square lengths by 2 square lengths. 1, 2, 3, 4, 5 by 2. The square lengths on the grids at this level, they are 1 centimeter, unless specified otherwise in the question. And that's the end of the questions.